Hello everyone. I'm very glad to be here today to share with you our latest work in CVPR 2022. The title is FocusCut, Diving into a Focus View in Interactive Segmentation. What is interactive segmentation? Interactive segmentation aims to obtain an accurate binary mask of the target object with the least interaction cost. Our work focuses on the click-based method, which is also the mainstream for this task because of its simplicity. For this interaction, users provide positive clicks on the foreground and negative clicks on the background to guide the segmentation of the target object. Here is an example. By continuously providing the clicks on mislabeled regions, a more satisfactory segmentation mask of the sheep can be obtained. Here, we will introduce our FocusCut. Let's take a look at how most of the current methods do it. We observe that current methods only perform the segmentation through the global view. That is to say, after the users take interactions, these methods consider input clicks together to generate the global prediction. However, this joint predicting process may weaken the decisive effect of the newly input click on its surrounding details. Let's focus more on the eagle claw and zoom in on it. We can see that the segmentation mask is somewhat unsatisfactory, especially for the gaps and boundary. Based on the observation, we additionally introduce the focus view into our method to refine the local segmentation. We can find that through the refinement in the focus view, the details of the eagle claw are more accurate. This is a simple illustration of our FocusCut. Then what does the pipeline look like? In order to reflect the effectiveness of our opinion, we decide not to change the architecture of the common used network as much as possible. It is worth mentioning that the basic network is regarded as a shared network for both global view and focus view. During inference, the first step is to feed the 6-channel input of the whole target into the shared network to generate the prediction in global view. Now let's look at the core focus view. The second step is to judge whether to focus for the current click. If the click meets the requirements, the focus scope will be calculated based on the variation between the current and previous predictions. Meanwhile, the previous prediction will be updated with the current one. The third step is to crop the patches from the original image for each focus click with corresponding scopes, respectively. The fourth step is to feed these 6-channel inputs of focus patches into the network to generate local predictions in focus view. The fifth step is to paste the patch predictions to the global one. And finally, output the final prediction. Here is a more detailed description about the focus scope calculation. With the newly input click, we get the previous and current segmentation masks. By comparing them, we can obtain the variation region around this click in local image. Centered by the latest click, we calculate the minimum scope of a square to cover this region, and finally give it a certain relax as our focus scope. We also provide a progressive focus strategy in our method. The smaller the focus scope is, the more detailed information may be focused on. By changing the scale dynamically according to the variation of the previous and current patch predictions, we gradually focus on areas that need to be repaired more. Let's see how our FocusCut turns out. We compare our method with others on the most common NOC metric, which counts the average number of clicks needed to achieve a fixed IOU value. The performance result shows that our FocusCut achieves the state-of-the-art performance on 4 widely used datasets. Here are some visualized results of our FocusCut. We can see that with the help of the focus view, the details around the click are segmented more finely. To sum up, our work has the above 2 contributions. First, we introduce a focus view to grasp user intentions in interactive segmentation. Second, we propose a simple yet effective pipeline FocusCut to strengthen the local refinement. The project page can be found by scanning the QR code on the right or visiting the corresponding website. Thank you.